Hi friends, welcome back to Edupedia World. In the last lecture, we saw the definition of mechanical energy and one of its kind, the kinetic energy. Today we will see the second type of mechanical energy, that is the potential energy. And in that we will see its two types, the gravitational potential energy and the elastic potential energy. So let us start with our lecture today. Potential energy. Potential energy. This is defined as the energy possessed by a body by virtue of its position or configuration. So potential energy is the energy possessed by a body by the virtue of its position or configuration. What does this mean? This means that the energy of a body can change depending on what position is it placed in. And a change in configuration, like what is the shape of the body. If you apply a force on the body, the shape will change. It will deform the body. So the configuration of the body is changing. So the configuration of the body also affects the potential energy. To sum it up, the energy of a body manifested by its position or the configuration is called the potential energy. So from the definition itself, we can see that potential energy will have to have two types of branches. One is by virtue of its position, which is broadly classified as the gravitational potential energy. This results in the gravitational potential energy, represented as PE, and the configurational part is the elastic potential energy. Elastic potential energy. So as we change the shape of the body has a natural tendency to go back to its original shape. So the changing of the shape of the body requires some work to be done on the body. And that additional work which is done on the body results in an increase in the potential energy of the body. So elastic potential energy is a positive quantity because work is done on the body to change the shape of the body, but gravitational potential energy by definition is a negative energy. Let us discuss the gravitational potential energy in more details. Now, gravitational potential energy, as we saw, is the energy possessed by a body by the virtue of its position. So if a body is lying on the surface of Earth, let's say this is the surface of Earth and the body is lying on the surface of Earth, and if we take the body and move it to a certain height h, then the potential energy, the gravitational potential energy changes. But by how much does the gravitational potential energy change? We can show this by a simple calculation as done here, that We know that the work is equal to force into displacement in the direction of the force. Now for any body, the gravitational force is acting downward. If the mass of the body is m, then the force is mg acting downward. We know this from our previous lectures. Then the body is being moved to a height h, and the force is acting in the direction opposite to the direction of motion of the body. Therefore, for this task to be undertaken successfully, the work has to be done on the body. You have to do certain work on the body. You have to increase the energy of the body from the energy here to the energy here. And that increase in energy will be equal to the increase in gravitational potential energy. So basically the energy difference between these two positions will be given as F is mg and the height lifted is h. So the gravitational potential energy of the block here with respect to the block here is mgh. What this means is that if we define the surface of Earth as zero gravitational energy region, then the gravitational energy at height h will be equal to mgh. And for the body to move from the surface of Earth to the height h, the work that will be needed to be done on the body will be equal to this mgh. This is the concept of gravitational potential energy. To sum it up, the gravitational potential energy of a body above the ground is measured as the amount of work done. Gravitational potential energy is the amount of work done to lift the body to that particular height. Now say that the body was initially at this position and it is later moved to this position, then actually negative work is done on the body. That is, the potential energy is decreasing. This is the basic concept of gravitational potential energy. Now, while we discussed this concept, while we found out mgh, we arbitrarily took the gravitational energy at the surface to be equal to 0, because what we needed was to find the difference in the energy between these 2 points. So we took it to be 0. But by the definition of potential energy, if we had to find the absolute value of gravitational potential energy on the surface, that would not have been 0. That has to be a negative number. The only place where the absolute value of gravitational potential energy is 0 is at a distance infinite from any mass. I hope this point is clear. The point that the gravitational potential energy is a negative quantity. It is a 0 at an infinite distance. For all other positions it is a negative quantity. But for this case at hand, we used the potential energy here as 0 because we had to find the difference of energy between these 2 points, difference of energy between these 2 points to find the work. Now let us see a few examples of conversion of potential energy to kinetic energy and vice versa. Let us take this example at hand itself. Suppose that the ball of mass m is lifted to a height h. Now, as we discussed here, this ball has a potential energy equal to mgh with respect to the surface. Now, if we drop the ball from this height h, then what happens? The ball will start moving towards the earth. As it starts moving towards the earth, the potential energy starts to reduce. Why? Because the height starts to decrease. Now, as the height starts reducing, the potential energy starts reducing, but the velocity of the block M, of the ball M, starts to increase. And as we have seen previously, the velocity of the body determines the kinetic energy. So as the body starts moving downward, the kinetic energy starts increasing. In this direction, the kinetic energy starts increasing and the potential energy starts to decrease. Therefore, what is happening here is the potential energy is increasing at the expense of the kinetic energy. This is an example where conversion of energy is taking place. Now, if we imagine just the opposite scenario, say we have a ball m here and we throw it upwards with a velocity v. So initially it had a kinetic energy. Now as the ball starts moving upward, from our practical day-to-day experience we can say that the speed of the ball will reduce as the height increases and it will reach a maximum height, after which it will start to drop again. So what is happening in the upward motion? What is happening is that V is reducing as the ball moves upward, as a result the kinetic energy is reducing, and that reduction in kinetic energy leads to an increase in potential energy. Why? Because the height is increasing, and as we saw that the potential energy is mg times h. So with these two examples, I hope you understand the relation between kinetic and potential energy, how the conversion between those two takes place in our day-to-day activities. With this understanding of potential energy, I will close today's lecture. In the next lecture, we will see numericals regarding both potential and kinetic energy. We'll see questions in which there will be conversion between potential and kinetic energy, and with that we will have a much more clearer picture about what we have discussed in today's lecture and in our previous lecture where we saw kinetic energy. Have a great day. Goodbye.